writing 12th, you're writing 10th. Great. I can see Shrutika sitting for their first class. I guess Divya. So you people are sitting for your first class of this academic year of physics, I'm saying. So for your information, I am in magnetic effects of electric current chapter, and I am basically in the second half of it. Half I have already taught. Today, whatever I'm going to teach, I'll try to make it simple for you. But even if you don't understand, don't panic much, because you're going to be taught everything once again from the beginning. So if you don't understand something, don't panic much. It is simple. You are in the middle of a chapter, that's why you may have some disturbances, but I'll try to make it as simple as possible. Just to recall whatever I have taught in the previous class, I have taught first about Orsted's experiment. Basically, the person who identified that there is a magnetic field produced by current carrying conductor also. So who was the person? Hans Christian Oersted. He was the person who found that current carrying conductor also can produce magnetic field around it. The moment he found that current carrying conductor has magnetic field around it, they were eagerly waiting to replace the permanent magnets with artificial magnets, bar magnets. So bar magnets, magnetic field, they wanted to replicate. So first topic in this chapter was properties of the magnetic field lines, also called as magnetic lines of forces. And the first property was it starts from north and exits or terminates in south externally and goes from south to north internally. Then you learned about some point like strength of magnetic field is given by the degree of closeness of the line. Lines are more close, magnetic field is more strong. Lines are more far, magnetic field is weak. Then you learned about tangent drawn to a magnetic field line gives the direction of magnetic field. You learned that no two magnetic field lines will intersect each other, because if they intersect each other, then at the same point you have two different directions, which is not possible. These were the properties of magnetic field lines. Then we learned about two experiments. Actually three experiments. One experiment was talking about magnetic field due to straight current carrying conductor. I taught you if we have straight current carrying conductor, then the magnetic field around it are in the shape of concentric circles. Magnetic field shape is concentric circles, and direction of magnetic field is given by right hand thumb rule, which says that if you hold a current carrying conductor in right hand with thumb pointing towards direction of current, then the four fingers will point towards direction of magnetic field. If current is going upwards, magnetic field will be anti-clockwise. If current is going downwards, magnetic field will be clockwise. But sometimes they talk about magnetic field in two dimension. If it is three dimension, we can say clockwise, anti-clockwise. If they draw a wire like this, current is going in the upward direction, and then they ask you what is the magnetic field at point A, then you cannot say in terms of clockwise or anti-clockwise. Rather, you should keep your thumb in the direction of current and try to see how your fingers are pointing, into the plane or out of the plane. In this case, it will go into the plane, so we will denote it by a cross sign. Cross means into the plane. So into the plane is the direction of magnetic field at A. What about this point? If it is B, it will be out of the plane. How we denote out of the plane? A circle and a round. This is out of the plane magnetic field. How I am drawing it? See, if I am holding the wire in right hand, my fingers are trying to come outside the paper. So it is out of the plane. So they may expect this from you in the board examination also, into the plane and out of the plane. So into the plane is given by cross sign, out of plane is given by dot and a circle sign. Okay. Then we learned about the experiment. Basically, the experiment was take a board, pass wire through it, spread some iron filings on it, tap the board. Iron filings will arrange itself in the circular patterns. If you have compass, you can see the direction of the magnetic field also. Then we learned about circular current carrying conductor. We learned in the previous class that circular current carrying conductor will have magnetic field like circles near the wires becoming straight parallel lines in the middle. And then we also found that, first of all, before that, we found that in this case, in the previous case, the magnetic field is depending upon two things. One is what is the amplitude of current, how much current is flowing inside. If current is more, magnetic field is more. If current is less, magnetic field is less. Second factor was distance of the point from the wire. It means if I have a point here and if I have a point here, point 2 will have lesser magnetic field compared to point 1 because magnetic field is inversely proportional to distance. The more closer you are to the wire, the higher the magnetic field is. And the more far you are, lower the magnetic field is. This also we learned in the previous class. And when I talk about circular current carrying conductor, the magnetic field depends upon two things once again. One is the current intensity, same once again. If you have more current, you have more magnetic field. Second factor was radius of the loop. If you have two loops having same current but different radius, here I am having 1 centimeter radius, here I am having 2 centimeter radius, then a 1 centimeter radius will have a bigger magnetic field compared to this wire which is having a radius of 2 centimeter, because magnetic field is inversely proportional to radius also. I told this in the previous class. Magnetic field is directly proportional to the current and inversely proportional to distance. So lesser the radius, stronger the magnetic field. More the radius, lesser the magnetic field. Then we spoke about solenoid, if I am right. When I spoke about solenoid to you, I said that solenoid is insulated copper wires wound in cylindrical form. So if you take copper wire and you are wounding the wires in cylindrical form and you pass the current through it, it becomes a solenoid. So when I connect it through a battery like this, it becomes a solenoid. It will have magnetic field around it. And surprising thing was the magnetic field produced by a solenoid is replicating the magnetic field of a bar magnet. So wherever we were using bar magnet, we started using this, that is the solenoid. Solenoid has very beautiful thing, which is it can magnetize the materials. If I keep inside a soft iron, it will create a temporary magnetism. That is, when you want to have a stronger magnetic field, then what do they do? In the solenoid, they insert a soft iron piece. A soft iron piece produces a temporary magnetism. It means whatever magnetism was coming because solenoid, it will add to it. So you'll have stronger magnetic field. Another thing is, if I insert steel inside, steel means some hard iron or cast iron, steel will become permanently magnetized. So if you want to make magnet for selling, then what we will do? Take steel piece, insert inside the solenoid, pass current, magnetic field will produce, magnetic field will magnetize my steel will become a permanent magnet. So when we are manufacturing magnets, permanent magnets, don't think we always go to the earth crust, dig and take out the, magnets. Not like that. We take steel and we put in the solenoid, we magnetize it, it becomes permanent magnets. If you have soft iron, it will become temporary magnet. I also told you that the magnetic field of a solenoid depends upon two things. Once again, current, and second thing is number of turns per unit length. Very important. If there are two solenoids, one has 100 turns, one had 200 turns, they both, if I ask which will have more magnetic field, you cannot say it is 200 turns. You should ask me what is the length of each solenoid. If I say 100 turns 1 meter, 200 turns 2 meter, then they both have same magnetic field because 100 by 1 and 200 by 2 is same. If I say both are having same 1 meter length, then 200 turns will have a stronger magnetic field because more turns per unit length. If 200 turns is having 3 meter length and 100 turns is having 1 meter length, then 100 turns solenoid will have greater magnetic field because number of turns per unit length is 100 here, there it is 200 by 3, which is going to be 66.67. So please remember, magnetic field inside a solenoid does not depend upon the number of turns, rather it depends upon number of turns per unit length. Okay, where do we use solenoids? I told you in electric bells we use it, in MCBs we use it, in separating garbage, junk from the, and there's where we use it. So up to here we have learned in the previous class. In today's class, we are going to go for the new topic. Give the heading as force on current carrying conductor kept in a magnetic field. Today's topic is force on current carrying conductor kept in a magnetic field. Those whose video is off, in 2 minutes, Revan sir put them in the waiting room. Don't allow them for the class. Force on current carrying conductor kept in magnetic field. Force on current carrying conductor kept in a magnetic field. Again, an important topic. Today we will learn how the questions are being asked from here. This is the topic which can confuse you. I am assuring you, one question in the board exam will surely come from here, and there are quite chances that you will make a mistake there. So be very clear in the concept. Okay. So imagine you have a magnet. Okay. And then you bring another magnet near to it. This is North Pole, this is South Pole. I bring another magnet near to it. North Pole and South Pole. What will happen? This will get repelled back. If I bring a magnet South Pole and North Pole, what will happen? So, without even touching the magnet, you could move it, right? Either it moves towards the magnet or away from the magnet, depends upon whether it is attracted or repelled. Why this movement is happening? Some force can only move an object that you learned in 9th standard. If an object is in motion, it is only possible if there is force applied on it. By itself, something can move. This bottle can move by itself somewhere. Cannot in the real world. This bottle cannot move by itself until some force is acting on it. Am I right? So, if there is a movement in an object, it means what is happening? Some force is acting on it. What is that force? Magnetic force. How it acts? It acts because of the interaction of two magnetic fields. This magnet will have its own magnetic field. This magnet will have its own magnetic field. When they are brought close to each other, the magnetic fields will interact with each other, and there is going to be some repulsion or attraction. Some force will act. So always remember that when there is interaction of magnetic fields, there will be a force acting. Okay, now coming back to this topic. So what the heading is? Force on a current carrying conductor kept in a magnetic field. Now just now I told you before like today's class that current carrying conductor is producing what? Magnetic field. Do you agree with me or not? If I have a conductor carrying a current, it will produce magnetic field around it. And we already have existing magnetic field. What will happen? These two magnetic fields will interact and the force starts acting on the conductor. That's all. The concept is when there is a current carrying conductor kept in the existing magnetic field, current carrying conductor will also have magnetic field and existing magnetic field is also there. These both magnetic fields will interact and there is a force acting on the conductor. Direction of this force is given by Fleming's left hand rule. First, write a statement of this. Write a statement. The statement is if a conductor carrying current, if a conductor carrying current is placed in a magnetic field, there is an interaction between the existing magnetic field with the magnetic field produced by the conductor. Magnetic field produced by the conductor. This interaction exerts force. And direction of this force direction of this force and direction of this force is given by Fleming's left hand rule. Fleming's left hand rule. Fleming's left hand rule. Fleming spelling F-L-E-M-I-N-G. Fleming's left hand rule. Fleming's left hand rule. Now you change the paragraph and give the heading itself as Fleming's left hand rule. Give the heading as Fleming's left hand rule. Rayan Ahmed, if you are hearing me, last warning for you on your video, man. Fleming's left hand rule. First, you write a statement and then I'll make you understand. Write a statement first. If we extend our first finger, middle finger and thumb, if we extend our first finger, middle finger and thumb, first finger, middle finger and thumb mutually perpendicular to each other, mutually perpendicular to each other, mutually perpendicular to each other in such a way that, mutually perpendicular to each other in such a way that, the first finger gives the direction of magnetic field. The first finger gives the direction of magnetic field. First finger gives the direction of magnetic field. Middle finger gives the direction of current. Middle finger gives the direction of current. Then first finger gives direction of magnetic field. Middle finger gives the direction of current. Middle finger gives the direction of current. Middle finger gives the direction of current. Direction of current. Then the thumb will point towards the direction of force. Then the thumb will point towards the direction of force. Then the thumb will point towards the direction of force. Then the thumb will point towards the direction of force. Okay. Now please pay attention. Imagine you have a magnetic field. What is magnetic field? What I am drawing is what magnetic field? Into the plane. You know what is the meaning of it? Meaning is magnetic field is going like this. Are you understanding it? How the magnetic field is? It is going into the plane. Direction of magnetic field is clear to you. It is going into the plane. Imagine I am having a conductor. Imagine I am having a conductor and this conductor is kept somewhere like this. And this conductor is connected to a source of EMF, a battery. Okay? Positive, negative. So current flows like this. Do you agree with me? Clear? So current is known to you. Magnetic field is known to you. What will happen? The conductor carrying current will produce a magnetic field around it. Already There is a magnetic field produced by whom? The existing magnetic field, into the plane magnetic field. These two magnetic fields will interact. If they interact, force will act. What will the force do? Let us check that. So first finger pointing towards magnetic field and middle finger pointing towards current. My thumb is pointing downwards. You know what is the meaning of that? It means that this conductor will start moving downwards by itself. A conductor kept here will start going down. Why? Because a force is acting on it in downward direction. I'll repeat this, those who are getting confused. The direction of force is given by Fleming's left hand rule. This rule says that extend your first finger, middle finger and thumb perpendicular to each other, like this, like how I am doing. So when you have them perpendicular to each other, first finger pointing towards direction of magnetic field, middle finger pointing towards direction of current, wherever thumb is pointing, that is direction of what? Force. So in this case, magnetic field was going into the plane, right? Current was going towards left. So I'm doing like this. Obviously, my thumb is pointing downwards. So the answer is downwards. In board examination, you will get questions from here only. From where? From direction of force. And great chance of doing mistake, because I'll tell you how the questions will be. Before I tell about the question, just write one more point. Change the paragraph and write. This force depends upon current, length of the conductor and the magnetic field. Current, comma, length of the conductor and magnetic field. Current, comma, length of the conductor and magnetic field. It means if there are two wires, one is carrying 2 ampere, one is carrying 5 ampere, then 5 ampere current wire will have more force. If there are two wires, one wire is 1 meter long, one wire is 2 meter long, 2 meter long wire will have more force. If there are two wires, one kept in 100 Tesla magnetic field, another kept in 500 Tesla magnetic field, then 500 Tesla magnetic field will have more force. Are you getting my point? So it depends upon three things: current, length and magnetic field. Directly proportional to everything. Is it clear to you? Force depends on what quantity is clear to you. Now take the question how it comes in the board examination. Take one question for understanding. Everybody take one question now. This is how they will ask in the exam also. The question is like, shall I? Okay, take the question. Question is, if an electron moves, from top to bottom, if an electron moves from top to bottom in a region, hello,
Sir.
yeah, who is this?
Help me.
Revan sir, has this person joined before also? Some random person. How they are getting our link? What you are sharing with your friends? Then This is a closed meeting. Who is doing this nonsense? You. Today only joined, today only started doing. Okay, whoever is doing, we'll catch them soon. Coming back to what we were doing. Please, please, please. The question was being given, right? If an electron moves from top to bottom in a region where magnetic field in a region where magnetic field in a region where magnetic field is moving from left to right, is moving from left to right. In which direction, in which direction, in which direction will the electron get deflected? In which direction will the electron get deflected? In which direction will the electron get deflected? Now think about this question. Take 2 minutes of time and tell me the answer. If you cannot, I'll help you, but give a try from your side. Think wisely and say the answer. I will expect everybody to say some answer. Think. Everybody, I'll take your name and I'll ask your answer. Okay? It's a 2-mark question. Yeah.
The electron will get deflected towards the north.
Towards the north. Okay. For making it simple, I'll give 4 options to you. Okay. For making it simple, I'll give 4 options to you. So, options are, first option, as Preetham told, north. Second option is south. I'll not give east and west. Third option is into the plane. Fourth option is out of the plane. Now I'll into the plane. Okay, okay. I'll take out of the plane. So I'll come one by one. Preetham, you say into the plane, right?
Yes, sir.
Okay, Rayan Ahmed, any answer?
North.
North, okay. Nitin, any answer? Nitin Raghav, whatever you say, want to say, yeah.
Sir, into the plane.
Into the plane. Darshini, what about you?
Sir, same sir.
Same means same to Rayan Ahmed or same to Nitin and Preetham?
Into the plane.
Into the plane. Srinidhi?
Into the plane.
Mridini?
Into the plane, sir.
Divya? Bah, following everybody. Sudarshan Pranav, give some other answer, man. Into the plane or what? North? South?
South.
South, very good. Since I told give some other answer, give this a different answer. Okay, Meghana, out of the plane. Nitin, changed it. Okay, okay, I'll come back to you. Meghana Nagaraj.
Yeah, sir.
You,
Out of the plane.
thank you. I thought you were sleeping. Okay, out of the plane. Yes, Shrutika. Shrutika, I not heard you. North. Okay, you can mute yourself. We'll start from here. Joshita, fast. Joshita, fast. Don't know is no option. 4 options. Do inky, picky, ponky, and tell the answer. Out of the plane. 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 Into the plane. Out of the plane. Out of the plane. Follow the crowd, yeah. Into the plane. Out of the plane. Into. Into. North. Out of the plane. So one boy, Sudarshan Pranam Anand says south. Two or three people have said north. Some have said into the plane, and majority have said out of the plane. Actually, the equal amount of into the plane, out of the plane. Huh? Say Tumbi. Purila. Majority, it's not election, man. It's examination. So majority will not win here. Let us see what happens. Now everybody please pay attention and understand the question, because this kind of question comes in the board exam itself. I'll give second question to you where the answer should be correct. You should not make mistake. This time you can make mistake. I'll teach you now. Pay attention. So I hope everybody knows, as you have learned in the previous chapter electricity, that if there is a proton and if it is moving, the current will have in the same direction. This current is called as conventional current. If an electron is moving, current will come in the opposite direction, which is called as electronic current. Is it right? Everybody knows this? If a proton is there, imagine it is going upwards, then current will also go upwards. If electron is there, it goes upwards, current will come downwards. So here the electron is moving from where to where? Top to bottom. So current will go from where to where? Bottom to top. So current direction is like this, bottom to top. Magnetic field, how it is going? Left to right. So left to right. Am I right? Current is going in the upward direction. Magnetic field is going from left to right. Where is my thumb pointing? Into the plane. So the answer is into the plane. Those who told the answer as into the plane, whether you thought in the same way and said the answer, I will not ask you this. If you thought the same way, perfect. If you randomly said or something else you thought and said, correct yourself. But did you understand how the answer is into the plane? The only thing which you may have missed is direction of current. You would have taken the direction of current as top to bottom because electron is moving from top to bottom. But you should understand that direction of current is in the opposite direction of electrons movement and in the same direction of protons movement. Okay? And then you put left hand rule properly, you'll get the answer. Take next question. Write the answer for this question and take the next question. Next question is, everybody please pay attention, okay? Next question is very interesting. If a positive charge moves from the behind wall, behind wall, B-E-H-I-N-D, Preranjan, behind wall, to the front wall, of a person sitting on a chair. Person sitting on a chair. And sitting on a chair, and the magnetic field is from the ceiling to the floor. Magnetic field is from where to where? Ceiling to the floor. In which direction will the charge get deflected? In which direction will the charge get Deflected. Take 1 minute and say the answer. Revan sir, you can just chat with that waiting room person and ask to reveal the identity. Who are they? If they are revealing their identity, you can join them. They may be from 12th standard, I think. Okay, anyhow, check that. Man, you focus on this question. Any answer? Guys. Answer fast. Shall I options? Okay. I'll give the options. Wait. Options are no, it cannot be same. Please pay attention. Towards the left, second is towards the option C, upwards, option D, downwards. Give it a try. Yes, guys. Towards the what is this, man? Up down. Hey. Fifth option E. Up down. What is that? And up down. Upward is okay. Down is okay. Up down. What will do? Tick both and come, huh? Okay. Anybody else? Left. Okay. Oh. Here. Any idea? Yes, Mr. Preetham Vaddi. What is your answer? On your camera and say the answer. Preetham, I not heard from you. If you said something also.
Towards the left, sir.
Towards left. Nitin, what is your opinion?
Sir, right to left one.
Right to left.
Sir, from right one to left one, sir, towards the left.
Towards left, you should say. Don't confuse it. Towards right to left. Left. Okay, fine. Yes. Let me not ask everybody now. We are running short of time. I can tell the answer to you. Just see whether it is right or not. First of all, we have to sit on a chair. All of you are sitting already. Let me also sit. After sitting on the chair, they say that proton is moving from my behind wall to my front wall. If this is the direction of positive charge, same is the direction of current. So current will be like this. Okay. Magnetic field is moving from ceiling to floor. So magnetic field is downwards. And the current is towards you. For you it will be towards me. For me it's towards you. My thumb is pointing towards my left. Answer is towards left. What the I told right. I hope it is clear to you. I hope it is clear to you. Is it clear? Take one last question before we close today. Question is, please guys, pay attention. Question is, if an electron enters a region if an electron enters a region, R is not a vowel, and I wrote, yeah, if an electron enters a region where the magnetic field is into the plane, where the magnetic field is into the plane. What is the path? What is the path the electron will take? What is the path the electron will take? Options I am giving you to confuse you more. First option is upwards. Second option is circular. Third option is downwards. Fourth option is into the plane. What you wrote the question? If electron enters the region, you can write one more thing here. It may confuse otherwise. You may write enters from left to right. If enters from left to right, enters from left to right. Electron enters from where to where? Left to right. Left to right. So now tell me the answer fast. Huh? Give a try, man. Downwards. Everybody. Sound circular. Downwards. Downwards. Don't know is no option. Do Inky Pinky Monkey and say the answer. Say something. Upwards. Joshita? Downwards. 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 Upwards. Downwards. Up, down, what? Downwards. Upwards. 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 Up. Down. 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 Dream. Into the mirror. Into the plane. Okay. Yes, Shrutika, fast, fast, fast. Time is not there. Fast. Upwards. Meghna.
Sir, upwards.
Divya, Mridini, Sudarshan. Divya, I took your name. Mridini, I took your name. I hope I am audible. Rayan Ahmed, Srinidhi, are they not able
Yes,
to?
sir.
What is the answer here?
Circular.
Circular. Oh my God. Nitin.
Sir, downwards.
Okay. Nitin, fast.
Sir, I didn't hear the question.
Did not hear the question. Very good. Leave it now. Pay attention. Everybody, before we close the class, last question, let me tell the answer. Go, man, go. At least have the courtesy of seeing the answer, not having any willingness to see the answer itself. Answer is as told by Srinidhi, circular. You keep quiet. Listen now. Understand the concept. Please, everybody, pay attention. Everybody, pay attention. Something very important. It's going to be useful in 12th standard also. This topic is there in 12th standard. Same topic that I'm going to teach now. Question is, there is a magnetic field. Am I right? Into the plane, if I'm right? How the magnetic field is? Into the plane. How the electron enters from left to right. You know very well, if electron is entering from left to right, current will go from right to left. So current is something like this. And magnetic field is into the plane. So magnetic field into the plane and the current is towards the left. The force will act in which direction? Downwards direction. So what you will write? You will write the answer as downwards. Is it right? Let us check. The moment it is trying to go downwards, direction of electron is changing, direction of current will change. If electron is moving down, whether current will still move towards left? No. If electron is going downwards, current will go upwards. See the direction of force now, magnetic field into current upwards, force towards left. Are you getting what I'm trying to tell? When the electron was going towards right, then the current was going towards left. If the electron is going towards down, the current will go towards upwards. And now what will happen? The force direction will change. Force will now act towards left. It means this electron which was trying to go down will not be able to go down. It will take a turn and go like this. Do you agree? Whether it will be able to go towards left? No. Why? Because now direction of current again changes. Magnetic field into current will be in this direction because the electron is going towards left, current will go towards right. Now the force will be which direction? Upwards. So it will go like this. Whether it will be able to go upwards? No way. Why? Because, hold man, 10th is going on. Wait that side, 5 minutes. Now what will happen? It will be trying to go upwards. Magnetic field will be acting downwards. The force will be acting in left direction. It will once again take like this. Finally, it will take a circular motion. You know what this is called as? This device is called as cyclotron, by which they are accelerating charged particles, which you will study in higher classes. But understand why the answer came as circular. Srinidhi, I don't know how you thought this. If you thought this, it's a very good thing. Otherwise, it's something new for you. Okay? So before you leave, I'll take the attendance alone. Huh? They may ask here, how we can judge what they are going to ask in the board exam. If question is tough, they may ask you also. So before you leave, give me a second, I'll take the attendance. Revan sir, you can stop the live.